I was talking about the relevant step in the BBM92 protocol, which relates to this, right? So this whole notion of information reconciliation and usage of an error correction code to kind of correct the errors without revealing secret keys. So this is, I guess, maybe the point of interest for this question, because depending on the error correction code that Alice and Bob choose for this, and depending on how that code actually works, it's certainly possible that when Bob is running his own secret key bits and this error syndrome through the error correction code, the code will output something, right? And it might not give a direct indication of whether this process failed or succeeded. Some codes do indicate that, for example, in LDPC codes, it wasn't possible to converge on correcting the secret key bits. But it's a matter of the code whether you actually get such a positive or negative confirmation of whether you actually succeeded. But even in the case where the code tells you something succeeded, there's still the small possibility that sure, the code succeeded in applying the error syndrome, but the outputs differ. So one way we can actually resolve this is by augmenting the information reconciliation part of the protocol with something called an error verification step. And what this might look like is that in addition to sending over this error syndrome to Bob, Alice might also compute a secure hash locally of her secret key bits and send this hash over to Bob as well. Depending on the strength of that hash or the security guarantees of that hash, when Bob now goes and computes the same kind of hash after applying the error correction code, there's some probability that the hashes mismatch, right? And so, depending on the strength of that hashing protocol, there is some very, very small probability that the hashes are the same, even though the secret key bit sequences fed into the hashing protocol are different after the error correction step. And so I guess a user an implementer of this system has the freedom to decide what the hashing algorithm is, and they can make the probability that the secret key bits are different but produce the same hash negligibly small, to the point where it's like a 1 in a trillion billion chance that we'll actually have different keys while still successfully going through these checks that further ensure that we do have the same stuff.